Nice microphone. So we're making do with a built-in microphone. I would like to talk to you briefly about the roles of mutation and testing and how they affect each other. Okay, so regardless of how you feel about testing, testing does turn out to be pretty much the only way to figure out whether or not a program works. Got to run some tests. All right, so here's our program. It's got some inputs on the left. It's got an output on the right. Does it work? No, it doesn't work. Of course it doesn't work. Programs never work. Programs certainly never work the way you expect them to, shall we say. Okay, so what are you going to do about it? Well, inside of your program, there's a lot of little bits and pieces. One approach, the diagnostic approach, would be to insert probes and examine what happens at various points in the middle of the program, much the same way you might try to fix an engine that isn't broken. Fortunately, your program is not an engine that is broken, but rather consists of a lot of little programs. And all of these little programs can, in fact, be tested. One might even go so far as to say designed independently. Okay, so we can run tests on individual components of programs. Let's take a look at what we might do in order to test a small component of a program. All right, we're going to blow up this thing into something larger, but keep in mind we're still looking at just a single function. So this function, we're describing its behavior by saying that when we call the function f with 13, 14 in the string horse, that it should return 15. This is a simple example or test case indicating whether or not this component does what it's supposed to do. If your testing framework makes you type a whole lot of junk in order to write this test, then it's not a good testing framework, and I don't have anything to say to you beyond that. Hopefully you can express this test in a concise form. What happens when you have mutation as part of your function? By mutation in this case, I'm referring to code that changes the value of some variable, or perhaps you'd like to call them fields. All right. In particular, the example here is we perhaps have some internal counter on the object that is being incremented. This change, this mutation, represents an extra implicit output indicated by the light gray arrow. If we want to test that this function is working correctly, it's not enough for us to discover that it returns 15. We must also check that the change in state happened, that was supposed to happen. And of course, things are usually much worse than this. Ordinarily, well, not ordinarily, it is often the case that we have many, many state changes. We have a void function whose only purpose is to make many internal state changes. Checking whether those things work correctly is very, very difficult. All right. There may be many things to test. There is often no way to observe them. They may be in private fields. And if, in fact, you're opening up to global state, then the number of things that you have to test is really very, very large. It's not surprising that someone living in this world is going to dislike writing test cases. And the solution, of course, is not to live in that world. Okay, so here's a little simple example. This is written in Java, and I am trying to diagnose a problem where it turns out that B does not have the right value. If I am not using mutation in my program, then what I need to look at is the value of O and the code in H, and the number 9. I do not need to know what A gets, or how G works, or how I works. I can pay attention only to the pieces that matter. All right, here's an extremely extreme example, and what you don't realize about this example is that it's not written in Java at all. It's written in C, which is perhaps a bit of a straw man, because C is not safe. Now, if B is wrong, where do I have to look? Well, in fact, the answer could lie in C as well, because, in fact, perhaps C is creating a local array and accidentally writing beyond its range and stomping B. All kinds of things can go wrong. You can't really regard a program written in C as being made up of independent parts in the same way that you can with another language like Java. But how do we fix it? Look, we solved the problem. Wait, these are just the same? Yes, it's true. They are just the same. The only difference here is that this piece of code is written without using mutation. So in other words, in this situation, I don't need to worry about all those other things that can go wrong. I only need to look at the definition of H. Again, this assumes that I'm using a language like, say, Java. There are two possible conclusions from this talk. One, mutation is wonderful and important and valuable, and testing is not. Right? On the other hand, and you may have inferred at this point that I belong to the second camp, you might also conclude that testing is great. And, in fact, you probably want to avoid mutation.